For the warm-up, I want you to take a minute and think about what the equations for each of these three graphs would be. These are all quadratic functions, so I want you to try to figure out what would the exact equation for each of those graphs be. So go ahead and pause the video, and then when you restart, you can see my solution to this problem. Alright, so I notice that the red function has the ordered pair 1, 1, and the ordered pair 2, 4. And then I can even see that it would be about 3, 9. So the red function looks like the parent function to me. F of x equals x squared. I just take the x coordinate and square it, and that gives me the y coordinate. If I look at the green function, it still is a quadratic. It still has a squaring in it, but I not only square that one, but I also multiply it by 4. This point would be 1 squared times 4. This point would be, this point right here is 2, it looks like 4 times, looks like 2, 16 here. So that would be 2 squared, which is 4, times 4 would give me 16. So the green equation looks like it's the same as the red equation, except after you square it, you multiply everything by 4. What I also notice is that the green equation has kind of been pulled up from the red equation. It's pulled up away from the x-axis. The blue equation is also the squared. It's also got an x squared in it because it's still a quadratic. But this time we take our x squared and we multiply it by a 4th. So we do 1/4 times x squared. That also fits with this point over here, which is labeled -2, 1. So I square -2, I get 4. I do a 4th of that, I get 1. So those are my equations, and what I notice about the blue one is that it's the same as the parent function, except it's been pushed down towards the x-axis. It's been spread out or compressed towards the x-axis. Today's lesson is going to be about whether we can generalize that to other types of functions, or is that only true for quadratics? So 10.5 is about compressions and stretches. So what changes to function equations will result in vertical stretches of their graphs? Today we're doing only vertical. I don't need you to write this down. I just want you to take a look at this. This is f of x equals x squared. And we're asking the question, how does multiplying a function by -1 change its graph? So if I want to take that graph and multiply it by -1, what happens is that takes that whole graph and turns it upside down. So instead of a smile, it's sort of a frown-looking graph. Here's the cube root function, which we learned about this chapter. The cube root function, and then if I multiply that one by -1, oh, look at that. It's the same shape. The red one is the same shape, except it's kind of turned upside down. So this is what I would write in your notes. Now's the time to write. I would write if g of x equals -1 times f of x, then the graph of g is a reflection across the x-axis of f. So how does multiplying a function by -1 change its graph? It makes it into a reflection across the x-axis. You might want to also sketch one example of that. So one of these examples, you could make a picture of this example, to have an example of that in your notes so you can see what I mean when you refer back to what does it mean to be a reflection. Oh, there's a picture of what a reflection looks like. Okay. Now here's an example for you to think about. F of x is the square root function, which we learned about this chapter. G of x looks like it's a reflection across the x-axis, so what would the function be for g of x? After you've made a guess, unpause the video and see what my answer is. Okay, my answer is that g of x would be -1 times the square root of x. We don't always write the -1, sometimes we just write negative square root of x. So that is the function reflected across the x-axis. Try to imagine what the graph of this would look like. It's a reflection across the x-axis. I'm going to kind of show you some points. So here's 2, 2. If I reflect that across the x-axis, it would wind up here. If I reflect this point across the x-axis, it winds up here. And so those points, as I'm reflecting each point across the x-axis, that's a reflection, and you wind up being the same point. Each point is a reflection across the x-axis. Oops. So this one is 2 down, so its reflection would be 2 up. This one would be 3 down, its reflection would be 3 up. So this is what a graph of the reflection looks like. Notice how that has a slope of -1 and the other one has a slope of +1. So now that's all example 1. That's flipping. Now we're going to look at multiplying not by a negative number, but we're looking at multiplying by a number that is, that should say greater than 1. Sorry. So we're multiplying by a number that's greater than 1. So we're going to multiply by 6 here. And notice that that graph, when I multiply by 6, takes that function and pushes it away from the x-axis. Same thing for the cube root function. If I multiply the cube root function by 3, that's going to take that function and push it away from the x-axis. It's already a little bit away from the x-axis, but it's pushing it farther away from the x-axis. So here's the summary for this one. If the absolute value of k is bigger than 1, then the graph is a stretch away from the x-axis. So if g is k times f of x, that stretches it away from the x-axis. This is for what I call big K. But I'm putting big in quotation marks because it's also true if you have a negative k. If you have like -6 as a k, that will flip your graph over the x-axis, but then also push it away from the x-axis. Okay, so this is a push away from the x-axis. Okay. So take a minute and just think through these in your brain. Write any function that would be a vertical stretch away from the x-axis of f of x equals x and of the square root of x. Here's an example of one that's a vertical stretch away from the x-axis. So f of x equals 10x. That would be pushing your points away from the x-axis. Here's a vertical stretch away from the x-axis of square root of x. I'm going to make it -2, so that's going to flip it over the x-axis and then also stretch it away from the x-axis. That's a vertical stretch and also a flip across the x-axis, a reflection. We're also going to ask the question, what happens if we multiply by a little k? A little k would be one that's less than 1. It might be negative, it might be positive, but what happens to the absolute value function, which is a v shape, if we multiply by a fraction or a decimal? And what happens then is we start compressing towards the x-axis. It pushes it closer to the x-axis. So x squared gets widened out and pushed closer towards the x-axis if we multiply by 0.5. Okay, this is what I would write for this one. So your absolute value of k is less than 1. G of x is k times f of x. So the graph would be a compression toward the x-axis. I'd probably also write an example of what that looks like. So draw a little graph there so you can show what that looks like. Take a minute and graph on your calculator a function that's a compression towards the x-axis of this function. So try graphing something like f of x equals, 0.1 times the cube root of x. Just a reminder on our calculators, if we want to graph this, we have to graph 0.1 times x to the 1/3 power. We have to tell it that that's what we want. Okay. I wanted to show you, because we're away from each other and it's harder to help each other with notes, I wanted to show you what I wrote down today. I wrote these 3 if statements, and I drew a little example of each one. So If you'd like to pause the video and take a look at my notes and kind of compare to yours to make sure that you have everything that you need from today, that would be fine. These are today's notes that I wrote as I went through the lesson. All right, thank you so much. Good luck today.